Hello, everyone. Thank you for joining my session. Today, I want to talk to you about BadZure, a tool that you can use to build cloud lab environments. Specifically, in this session, we're going to talk about how BadZure can leverage Gen AI and LLMs to build cloud attack labs. Just a quick introduction about myself. My name is Mauricio Velasco. I'm originally from a city called Arequipa in Peru. Recently, I joined CrowdStrike as a cloud security researcher. And before that, I was at Microsoft and Splunk also as a security researcher. If you're interested about the topics of detection engineering, threat hunting, or adversary simulation, I encourage you to visit my GitHub page and my Twitter account where I share my work. Okay, so I wanted to start the presentation with a simple question. Where do you experiment with cloud attacks? Let's say you read a blog post or you read a threat report and you want to explore a new Entra ID attack end-to-end, or let's say you are interested about managed identity abuse or key vault theft. Where do you actually do that? Somewhere where you can safely break things and analyze logs. I hope your answer is not your production tenant. That's why I think that every cloud practitioner needs a range, a realistic, disposable lab environment, a place where you can explore cloud attack paths as many times as you want. Red teamers can use these ranges to rehearse cloud tradecraft, to test the efficacy of a new tool or a new technique. Detection engineers and threat hunters can use it to analyze telemetry, to validate detection ideas, to validate hunting hypotheses. And purple teams can use it to reproduce a specific TTP on demand. However, building a cloud range and all the different components required to test a specific cloud attack technique by hand can be a tedious task and can take time. That's why I wrote BadZure, a project born out of my own desire to explore and learn about cloud attack techniques. It's a tool that enables security practitioners, a tool that allows you to easily build cloud ranges. Initially released in 2022 as a standalone PowerShell script, BadZure has significantly grown since then. Under the hood, it's Python driving Terraform. One command allows you to populate tenants with hundreds of identities, cloud resources. And one command also allows you to tear it all down so you can try again. So you can follow this loop of populate, explore, and purge, and then repeat. It builds in two layers. First, the baseline. The baseline populates a tenant with all the moving parts a real organization has: users, workload identities, cloud resources, and permissions scattered across all of them, just like a real org. Then it layers intentional attack paths on top of that noise. I wanted to add that baseline because an empty tenant with some attack paths is just not realistic. Attack paths hide in the mess of this noise, and that's what the baseline provides. It spans both planes, so the identity plane and the cloud plane. So it's able to populate Entra ID tenants with identities, but also populates Azure subscriptions with cloud resources. And it builds attack paths across them. So for example, you could start an attack path with a compromised identity, pivot through a cloud resource by abusing it, and so on. So let's unpack those two layers, starting with the baseline. The goal of the baseline is simply to mimic a real organization, to approximate the shape and the mess of a real tenant. So what goes into that? First, people in structure. Randomly generated users organized in groups and administrative units with memberships, and essentially an org chart that looks like a company. So we're not going to have user 1, user 2, user 3. We're going to have randomly generated usernames, randomly generated groups and administrative units that look real. Then the workload identities, so the non-human identities, app registration, service principal, managed identities that are common in real tenants. On the Azure side, a spread of resources attackers can actually target. key vaults, storage accounts, virtual machines, web app, function apps, logic apps, etc. And the last piece, which may be the most important one, the permission sprawl. BadZure will randomly scatter Entra roles, graph permissions, Azure RBAC roles across all of the different identities created, just like a real tenant has in the real world. So that's layer one, that baseline. Layer two, on top of the baseline, is the attack paths. So BadZure will inject misconfigurations that create attack paths. But what is an attack path really? Consider this a scenario. You have a tenant that has a virtual machine with a managed identity. In Azure, managed identities let a resource have its own identity, so they can talk to other resources and consume services. So in this case, the managed identity has access to a sensitive Cosmos DB database. Now consider a user that through a group membership is granted the VM contributor role on that VM. This is totally normal, right? This is just how organizations deploy their cloud environments. But that VM contributor role actually allows a user to run code on the VM. So that's when this attack path arises. If an attacker is able to compromise that starting user, they can abuse their this Azure RBAC role that they got through that group membership to run code on that VM. So they can steal the managed identity token, they can become that managed identity, and then access that database and exfiltrate confidential information. So in BadZure, that's a cloud attack path. Just legitimate access, a chain of legitimate access abused. And notice here that the attacker never has to exploit a vulnerability, or CVE, or zero days. Every step was legitimate access handled on purpose. This is what an attack path is in the context of BadZure. So how does BadZure build these paths? Well, as we have just established, an attack path is essentially three things: principals, permissions, and resources wired together in a specific way. So a specific arrangement of legitimate building blocks that happens to be abusable. So those building blocks, we're already able to deploy with Terraform. But Terraform has no idea of what's dangerous, right? So that knowledge is what BadZure adds. I analyze public common privilege escalation techniques attackers use and distill that knowledge into the tool so that BadZure knows how to arrange the different pieces so that an actual attack path comes out of the other side. So Terraform is the hands and BadZure is the brain. And all of these attack paths get built on top of that baseline org. So we're reusing those users, those groups, those resources that we created by the baseline so that the attack path is buried in the sprawl. So it actually looks real. So what techniques are actually supported by BadZure? So like as I mentioned, I took a look at known techniques that have been abused by attackers, have been presented by researchers out there. And I organize them into identity plane and cloud plane. First, in the identity plane, the goal here is to hijack a privileged identity. So there are specific permissions and Entra ID roles that can be abused. For example, the application ownership abuse, by which a user who is an owner of an app registration can add a secret and then be able to authenticate as a higher privilege service principal, for example. Or perhaps the managed identity abuse, in which certain resources that have managed identities, if certain permissions are given to users, they can abuse the permissions given to those resources to hijack the managed identity and then escalate privileges. If we move on to the resource plane, once an attacker is able to abuse access to a resource, such as a key vault or a storage account or a Cosmos DB, and assuming that secrets are stored in these resources, for example, in the case of a key vault, a secret, in the case of a storage account, a certificate, then an attacker perhaps can abuse access to these resources to steal secrets and then use them to authenticate as another identity. So these are the 7 techniques supported as of today, and I'm working on more across the 2 planes. So now let me show you how BadZure can create a real attack path. So here's what we have today, and here's what we have in this first demo. Let's take a look at this graph. So let's say we have a VM exposed to the internet, which sometimes happens, right? This VM has a managed identity, and that managed identity has a role that allows it to read a storage account. And in this scenario, that storage account is actually storing a private key, a certificate for a particular app registration. And then that app registration has permissions, specifically Graph API permissions, that allow it to read OneDrive files from anyone on this tenant. So this is the first attack path that we're going to create with BadZure in our first demo. So let's go ahead and do that. Okay, so first, let me show you that I have my tenant here that doesn't have any users other than my administrative users. I have no app registrations other than my deployer, BadZure deployer app. The one that we're going to use, BadZure uses to actually deploy this environment. And we have no resource groups on this subscription, and then no VMs, okay? All right, so let me show you. This is the YAML configuration file that will deploy this lab environment. So BadZure uses YAML configuration files, okay? So first we have, of course, if you want to get more details about how the YAML look like and what are all the possible parameters and sections, please read the documentation on BadZure.com. But essentially, we have first tenant details. So I have my tenant, the domain, and the subscription ID. And then we have the baseline that we want to create. So we're defining the identities that we want to create. We're defining the different resources that we're going to create. So key vaults, resource groups, storage accounts, virtual machines, etc. And then the assignments. So these are the random assignments that BadZure is going to create against the baseline identities so that our environment looks realistic. And then the next section is the attack paths. In this case, we only have one attack path, and attack paths have 3 sections. So initial access, in this case, we're picking an RDP. So we're going to have a Windows server exposed to the internet with a weak credential. And then the previous escalation technique is going to be managed identity abuse. And then this managed identity will have access to a storage account that will store a certificate for an app registration. And finally, the app registration will have this permission. So as you can see, we can define all the details about this particular attack path within the YAML file. All right, so then I have BadZure here, everything's ready. So all I have to do is call the build command and pass it this parameter, the YAML file that we just went through. So BadZure gets everything ready and calls Terraform and starts deploying things. So of course, this takes some time. But while that's happening, I can show you what BadZure generates. BadZure will generate this file that gets passed to Terraform, and in here you can see all the details that BadZure is going to create, all the users that BadZure will create, all the groups, all the applications, the app registrations, the resource groups, the key vault. So these are all the details what BadZure is going to create. Okay, as you can see, there's a bunch of things here. So at this point, we just have to wait for Terraform to do its job. So I'm gonna stop the video here, or pause it rather, so that we don't have to wait until this finishes and then come back when BadZure is done. All right, so once BadZure finishes, this is what we get. We get the attack path details, and then we get some statistics. In this case, it took 5 minutes to deploy this lab environment. We created 25 identities, 13 resources, and then 39 assignments, out of which 31 were related to the baseline, and only 8 were focused on the attack path. So let's go ahead and look at the attack path details, and let's get the initial access is this VM that was created by BadZure. So let's have a look at some details on the Azure tenant. So as we can see now, some users were actually created, some app registrations were actually created. And then as you can see here, now we have 5 resource groups with a bunch of resources. But let's focus on the VM that BadZure picked as the initial access. As you can see, this VM here has a public IP address. And if we look at the networking details, you'll see that we actually have exposed to the internet. Okay, so now let's look at the managed identity for this VM. We can see that it has managed identity. And if we look at the Azure RBAC roles for this managed identity, we see that it has some roles for this storage account. And in storage account, if we look at the containers, we actually see that we actually stored here a certificate for this data scheduler pulse app registration. And if we look at our app registrations here, we'll see that indeed this app registration does have a certificate created that was created by BadZure and then stored in that storage account. And finally, this app registration has the files that read all permission. So this is how, with one configuration file, BadZure, we created this attack path here. Okay. So getting BadZure to this point was exciting. 7 privilege escalation techniques supported, configurable, deployable into a real tenant with a simple configuration file. But the more I used it, to be honest, the more I kept running into limitations. First of all, attack paths can only contain one privilege escalation technique, start to finish. Real intrusions, real attacks don't look like that. Attackers are going to chain multiple techniques to reach their goal. The second is that the manual work involved. Every one of these paths had to be handwritten as a YAML configuration file, every principal, every permission, etc. And honestly, I didn't want BadZure users spending their time writing config files. What if users can simply describe the attack paths they want? So I started asking a different question, right? Could AI enable BadZure? Not to replace the tool, but to bring the imagination of large language models so that they can chain a set of supported techniques together into long, innovative, novel attack paths that would be really tedious to write by hand. So that was my new goal. I wanted BadZure users to be able to describe attack chains they want deployed in their cloud ranges in plain language and use LLMs to write the config for them. So nobody had to write YAMLs anymore. And it took me, honestly, a few tries, a few failed designs to figure out how to actually get there. One thing that I learned is that we needed to move away from describing techniques in the YAML and rather expose primitives underneath. So the identities, the resources, the permissions, expose these primitives to LLMs and let AI compose them into paths. So let's talk about that. This is one I implemented a re-engineering of the YAML configuration file. So if you think about it, each one of these supported privilege escalation techniques is actually composed by a handful of primitives, like defining the identities, the resources, the assignments, the credentials, the planted secrets. That's the whole vocabulary that we can expose to an LLM and allow it to chain them in interesting ways. I needed to describe the environment, not the technique. So instead of naming a particular technique, hard-coded technique, I wanted the YAML file to be able to describe the environment. So who exists, what exists, who can act on what, where a secret is hidden. So not specific canned steps. You don't ask BadZure to do a managed identity abuse. You just simply describe a VM, a storage account, and a permission between them, and a certificate in a blob, so that the attack path is built from those pieces. So it's a finite vocabulary and that allows us to create countless chains. And of course, this new configuration file could be written by humans or AI. So we're not necessarily limiting only for AI to create this. So this is how it looks like. If you remember, we had here, this was the YAML configuration file that we used to create demo number 1, which describes the previous escalation technique, where here is the new method where this hasn't changed, but we're no longer defining the specific techniques that we want. We're simply defining, here are all the identities that I need, here are all the resources that I need, and here are all the assignments. So by defining this, by describing the environment into these main sections, then attack paths can have multiple privilege escalation techniques in one. And yeah, when I first, after implemented this, and then I started exploring LLMs, creating these new YAML files, I came across a lot of hallucinations. The attack paths looked right, the YAML was valid, the story made sense, but when you actually tried to walk them, they didn't work. Either the certificate, the chain needed was not registered on the app registration, or the permission needed to run a runbook on an automation account wasn't there. The path read well, but it just wasn't reachable. So that's when I spent time defining the proper guardrails to ground LLMs. First constrain the model so it doesn't get to write free-form text. It has to describe the attack and the environment in that same YAML schema you just saw, using only the primitives that BadZure supports. The YAML becomes the vocabulary. It cannot invent a new syntax. It has to reference the building blocks supported by the tool. And second, the most important is that I needed to back the process with deterministic checks. Actual code that validates the YAML, that resolves every reference, and that proves the path can actually be reachable. So we can let the model be creative, but the verdict has to be deterministic. I think the most important check that I wrote was the reachability check. This is actually a command within BadZure that will catch the most difficult hallucinations. A path that looks valid, but it really doesn't work because it's missing a particular permission. This deterministic check actually walks the graph offline from that initial foothold to the final objective. And it proves that every hop is reachable. And if it's not reachable, it's going to provide where the error lies. So we can provide this feedback loop to the LLM, and the LLM knows what to fix. So let me show you how my initial approach to building this, to POCing this. I've defined splitting the work across a crew of agents. The architect is the one you talk to. It runs the other agents and holds the deploy button, you want to call it. The org builder agent stands up the realistic company, so creates that org structure with realistic users, groups, and etc. And then the adversary agent, that's the one that composes the attack path. And then the gatekeeper agent is the actual one that proves that the attack actually works. This is the one that actually calls the deterministic checks to validate if the chain is walkable. And it will get some feedback back from the deterministic check, so that agent can then try to fix the YAML if something is broken. This is still proof of concept, right? At the moment, this crew of agents is built on Claude agents, but my hope is eventually to be more agnostic. Okay, so on the first demo, we created a lab environment by manually crafting a BadZure YAML configuration file. And in this demo, we're going to leverage a crew of agents to build the YAML file for us, given a prompt, and then we're going to deploy it. So let's see. Okay, so before jumping into the actual crew of agents, let me walk you through some of the tools, some of the commands that BadZure supports to enable the agents. So for example, if one of the agents wants to understand what is the spec, what is the vocabulary that the YAML supports, he can call this command and it will get the vocabulary, the structure that is supported, so it knows not to hallucinate. Another quick check is the reachability check, as I mentioned. If I show you a couple of minutes ago, here's the YAML configuration file for the first demo in this format. And then here we have a similar one that is broken, that I deliberately made a mistake at. So let's assume that the agent would create the right one. This is the check that it calls, and it would say here, this is reachable. So the attack path is reachable. So it makes sense. But if we call the broken one, we'll see that this is not reachable, and it actually provides some feedback. It says, the certificate targets this app, but there's no certificate register. So then the agent knows, oh, I made a mistake, and now it will autonomously fix it and then call back. So these are some of the checks that agents have available at their disposal so they can create. So, okay, so now let's run this, the crew of agents. So we're going to call BadZure init. I do get this error, but that's okay. It still works. I had to change some prompts to avoid being... so here's the architect agent, and it walks you through the steps. But I already have a prompt here that I'm going to use. So in this prompt, I'm asking the crew of agents to build a realistic Azure and Entra lab for this made-up organization, 50 employees, mix of departments. We want some resources like Vaults, Cosmos DB, App Service, Logic Apps. And then we also want to design a multi-hub breach that starts with a vulnerable web application, and then pivots through Azure automation layers or logic apps and automation accounts being abused to finally get global administrator. So the architect agent will kick it off to that first agent, the org builder. So the org builder will take this prompt, and then start crafting this fake organization. So we can go into the org builder and see what it's doing. It's going to call that spec, and it's going to sometimes even read BadZure's code, read the examples that the BadZure repo has, and use that as a reference, as you can see here. So each one of these agents takes some time, right? I think the org builder takes a couple of minutes. The adversary agent can take up to 5-6 minutes. So of course, we're not going to wait just looking at this, at the agents working. For the sake of the recording, I'll pause and then come back with this finishes. Okay, so let me pause the recording. So the org builder agent finished in a couple of minutes. You can see that it wrote a design, and then it gives us a summary of what it created. We can actually see that it created this, generated a YAML. So here's the YAML for that first part, just the org, no attack paths yet. And of course, looking at this can be a bit tedious. That's why I implemented a really cool feature, a feature that I like a lot, which is BadZure can actually create an interactive report, an HTML report that the agent will call. And here's the report. Up until this point, we have identity, Azure resources, and assignments, so we can see all the users that will be created, the groups, applications, service principal, service principals, administrative units, and then the assignments. But one thing I really like is the graphs. We can see here, okay, it's going to create 51 users, 7 service principals, 4 managed identities. Here are all the groups that is going to create. Here are all the administrative units, and here are the Azure resources. So in this case, we're going to have four resource groups. These are the resources that will be created. And then the assignments. We can see here's like part of that permission sprawl. These are how many Entra ID roles are going to get randomly assigned, the Azure RBAC roles, and so on. So you get the idea, everything that will create it. So at this point, we could tell the architect, I don't like this, please add more users, please add resource groups. But I'll just say, this looks good. Let's move on to the attack path. So then the architect agent is going to now call the adversary agent, and the adversary agent is going to take that prompt and then try to create that attack path. There you go. That's the adversary agent there, creating that attack path. And then this takes a little longer. Sometimes there's multiple iterations. It identifies errors, it fixes them. So once again, I'll pause this and come back once our adversary agent is done. So our adversary agent took around 8 or 7 minutes to complete. We can see some of the reasoning here. Checks the configuration file, read the vulnerable examples, and yeah, just it fixed some errors. Actually, there was a loop there, but here's when it actually finally added the attack path to that generated a YAML file, and provided us the output. And now the gatekeeper agent wants to run that check to validate, will allow it to run the check to validate that the attack chain is actually reachable deterministically. So let's see how that comes back. And yep, it is reachable. So now we do have, on the report, we do have the attack path here, remote code execution and interfacing web application, etc. So they are all the steps. And I've created 2 graphs for the attack path. The first one is a posture graph, which describes the posture, the state of the environment for the attack path, which we're not going to go over. As you can see, it's a bit long. But then the attack graph itself, and this describes the attack steps from an attacker perspective. So the attacker exploits this app service, which is a web app, right, that has a managed identity, so it's going to steal the managed identity to then execute code on this logic app that has another managed identity that reads a key vault secret, steals that secret. You get the idea. So now we've created, with the help of LLMs, a chain, an attack chain that leverages multiple privilege escalation techniques to achieve a goal. And this was all deterministically validated. Now, so at this point, I am done. We are done. We actually have a full YAML configuration file created by this crew of agents. And now we can just call BadZure as we've done before. I've done that already here. And as you can see, it took 10 minutes to deploy all the different resources. And it created 83 identities, 15 resources, 222 total assignments. And we get some details about the initial access, which is this app service. So let's take a look at that real quick and see how that looks like. So as you can see, we actually do have that app service created. And if we click on that app service, we see that this is the initial access, right? So let's open this here. This is our vulnerable web application. And this is the initial foothold. As you can see, it does have a managed identity that has RBAC permissions to, let's see, this logic app. And this logic app has another managed identity that allows it to access these key vaults, or the chain. We can see the chain, right? Now, as I mentioned, BadZure deploys a really simple, vulnerable web application that is vulnerable to code execution. So by running this, I can should be able to get that. There you go, the token for that managed identity, and we can start our simulation to achieve the final step. So that was our demo. We successfully created a cloud range with a crew of agents. So I hope you enjoyed this. If you're interested about BadZure, here's the GitHub page. Please, if you like it, give it a star. I'll be pushing the latest code soon. And yeah, BadZure is the tool to create environments, but I have another tool that actually can execute simulations. So if you're interested about that. But that's all, folks. I really appreciate the time and hope you enjoy this, and do download the tool, play with it, and let me give me feedback if you have any. All right. You guys have a great BlackHat. See you on the next one. Bye.